Okay, our natural numbers, 1, 2, 3, so on. Our whole numbers bring 0 in. Our integers bring in the negative whole type of numbers. Rational numbers, any number that can be written as a fraction. For example, -3, right? You could write that -3 over 1. Also, like 0.3 repeating, right, is 1/3. So any of your repeating decimals, 0.6 repeating is 2/3. Irrational, any number that cannot be written as a fraction. And for example, pi, or our irrational number e. As far as inequalities go, x here is going between -3 and 5. So we're going to say x is greater than or equal to -3, but less than 5. So we're going to count -3, not count 5. So counting the -3 is a hard bracket, not counting the 5 is a soft bracket. Next one, we're going to put our less than or equal to. It's x is actually greater than or equal to 2 if we're reading from right to left. And then from left to right here, x is less than or equal to 6. So that'd be hard bracket 2 to 6. Both have hard brackets. Here, x is less than or equal to 1, which is -infinity to 1, hard bracket on the 1. It is important that you write it in that order, -infinity to 1, not 1 to -infinity. Interval notation always has to go left to right, smallest to largest. So you have to be going, left to right along the number line. Next one, we've got arrows in 2 directions. So we are going to have an or. So this is x is less than or equal to -1, or x is greater than 2. So that would be -infinity to -1, hard bracket u, and then soft bracket 2 to infinity. If a number is included, the circle will be closed, and that is denoted with a hard bracket. And if the number is not included, the circle will be open, which is denoted with a soft bracket. Infinity is always a soft bracket because basically you cannot count infinity. It's not a value. Okay, so as far as polynomials, the degree of a term just being one, one term, one expression, one monomial is basically what I want to say. The degree will be the exponent. So here the degree is the 3. If you have, again, one monomial, but there is more than one variable, like we have an a and we have a b, the degree is going to be the sum of the exponents. So the degree here is 3 plus 2 or 5. If you have a polynomial, the degree is going to be the degree of the highest degree, I should say, of any one of its terms. So this is a degree 2. This is a degree 3. The 1 actually has a degree of 0. And that's because you could write it like 1x to the 0 power, because anything to the 0 power is 1. So then that would go back to 1. So the degree of this polynomial, so degree of polynomial is 3. Because the highest degree of any one of its terms is 3. Standard form is just written highest exponent down to lowest. So they're just showing you standard form there. Leading coefficient, it's the coefficient of the term with the highest degree. So either you just scan and see which one has the highest degree, which is the 7x to the 5th. So the leading coefficient is 7. Or, sometimes people will say, well, leading, wouldn't that be the first one? Well, it is the first one if you were to rewrite this into standard form. Then it is the first one, the 7. Constant is a number without a variable. So the constant in this case is the 4, the number without the variable. Okay, adding and subtracting. There you're just combining like terms. So you look for your like terms. Let's see, I've got a 5x to the 4th minus a 3x to the 4th. So it's a 2x to the 4th. Then I look for my x cubes. I only have one of them. So 5x cubed. Then I look for my x squareds. So that's 11x squared. And then finally I have 4 minus 6, which is a negative 2. With subtraction, you just have to remember to distribute the negative to the second parentheses. So the first parentheses stays the same. Second one, we distribute the negative. And then it just becomes like the last problem. We're combining like terms. So we have a negative 8x to the 4th. That's that one. So we're done with that. Oops, I think I accidentally wrote that as squared, and it should be cubed. Okay, so for these two, then we have a negative 2x cubed. We've got our negative 6x plus a 4x, which is a negative 2x. And then 6 minus 4 is 2. Okay, with multiplying monomials, multiply the coefficients, add the exponents. So if we multiply the coefficients, negative 4 times 3, negative 12. We add the exponents, so it's p to the 3 plus 5, which is 8. And then q to the, remember this is q to the first, even though they don't write it. So then that's q to the 8th. Multiplication of polynomials, you have to distribute. So the 6p squared is going to go to both of these. The negative 3p is going to go to both of these. And then the negative 2. So for the 6p squared going to the 2p, we're multiplying, so that's a 12p cubed. Then the 6p squared with the 6 is a 36p squared. Then we do the negative 3p to the 2p, which is negative 6p squared. The negative 3p to the 6 is negative 18p. The negative 2 with the 2p is negative 4p, and the negative 2 with the 6 is negative 12. Then just becomes what we were doing before, which is combining like terms. So this is plus 30p squared. These are minus 22p minus 12. Next one would be the same thing, except here you're distributing to 1, 2, 3. Here you're distributing 1, 2, 3, and same thing with the 7. I'm going to, oops, I'm going to skip that one. Here you have to write this out twice and FOIL. You cannot just square the 4x and square the 3y. When there is that minus sign in the middle, a minus or a plus, you have to write it out twice in FOIL. So this is 16x squared minus 12xy minus 12xy, and a negative 3 times a negative 3 is a positive 9, and then y squared, because y times y. So this is 16x squared minus 24xy plus 9y squared. This one would just be written out 3 times. And first, you would do the first two, right? Just like, think about if you're multiplying 3 numbers. You'd multiply the first 2, get your answer, and then you'd multiply by the third. So I'm going to multiply the first 2. That'd be x to the 4th minus 2x squared minus 2x squared plus 4. That's all getting multiplied by x squared minus 2. I would probably clean this first polynomial up, get it as simple as I can. So x to the 4th minus 4x squared plus 4, then times the x squared minus 2. And then it follows the same as that example up above that we did. The x to the 4th will go to both of these, then the negative 4x squared goes to both of these, then the 4 goes to both of them. So I'll just write out here what you would get if you distributed that, and then leaving your answer to be x to the 6th minus 6x to the 4th plus 12x squared minus 8. Okay, division by a monomial. All right, if you're dividing by a monomial, just one term you're dividing by. You have to divide every single term in the numerator by that 4x squared y squared. So basically what you're doing is you're taking 4x to the 10th y to the 3rd, and you're dividing by 4x squared y cubed, minus, then you're taking the 36 x to the 18th y to the 18th, and you're also dividing that by 4x squared y cubed, and then you're taking the 20x to the 4th y to the 9th, and you're also dividing by 4x squared y cubed. Okay, so here, now when you're dividing, we divide coefficients, subtract exponents. Okay, so 4 divided by 4 is 1. X to the 10th divided by an x squared. We subtract the exponents, so it's x to the 8th. Y to the 3rd divided by y to the 3rd is 1. I don't need to write times 1 here because times 1 is just that thing. So x to the 8th times 1 is just x to the 8th. 36 divided by 4 is 9. That'd be x to the 16th, y to the 15th. 20 divided by 4 is 5, x squared, y to the 6th. So that is the answer. Use synthetic division when dividing by a degree 1 polynomial. So since this is an x to the 1st, I can use synthetic division. I can put the negative 4 in the box. That's whatever makes this 0. So I'm saying x plus 4 equals 0. X is negative 4. That's what's going to come over here in the box. And then I'm going to write this in descending order. So it's a 3x squared, 4x, and a negative 1. So you want that in descending order. And then synthetic division goes bring down the first number, multiply, negative 12, add going down. So you get negative 8. Multiply, negative 4 times negative 8, positive 32. Add going down, get 31. That is your remainder. Now, sometimes they'll ask you to write your answer in, summary form with the quotient and the remainder. So I would say 3x minus 8, right? If that's my remainder, that's my constant, that's my x term. So it's 3x minus 8 plus the 31 over the divisor, the x plus 4. Sometimes they'll just say, what's the quotient? What's the remainder? The remainder is the 31. The quotient is the 3x minus 8. So when they just ask the remainder is the 31. When you're writing it in that quotient remainder, like summary notation, that's where you're putting that 31 over the x plus 4. All right, long division. So if you're dividing by a polynomial degree 2 or higher, you have to use long division. So for instance, in this example, I'm taking the I'm taking the 3x squared plus 2x plus 4, putting that into 3x to the 4th minus 7x to the 3rd plus x squared minus 7x plus 9. Okay, so when you do long division, what you're going to do is you're taking 3 terms, you're putting in the 3 terms. So the first term you put is going to be right up here because you're doing 3 into 3. So it goes right above there. You're going to ask yourself, what times 3x squared is going to give you 3x to the 4th? The first here times the first here should give you the first here. So what times 3x squared gives you 3x to the 4th? That's x squared. So then you take that 3x squared and you are going to distribute it to all 3 of these. So 3x squared times x squared is 3x to the 4th. 2x times x squared is a plus 2x cubed. And x squared times 4 is plus 4x squared. Now, one thing that's different with long division from synthetic division is you subtract going down. When I subtract, I'm going to change the sign. So minus, oops. Oh, I didn't want that. I thought I could change maybe the color. Yeah, that's what I want. Okay. So I want to go minus, minus, minus. Okay, so these first ones should always cancel out. That's why you make them match. So when you subtract, they're going to cancel. This is a negative 7 minus 2, which is a negative 9x cubed. And this is 1 minus 4, which is negative 3x squared. Then you bring down the next. And then the process starts all over again. So you're going to say, okay, what am I going to put up here so that when I multiply by 3x squared, I get negative 9x cubed? So what you put here times the first here has got to give you the first here. So that would be a negative 3x, right? Negative 3x times 3x squared is negative 9x cubed. Negative 3x times 2x, negative 6x squared. Negative 3x times 4 is negative 12x. So you're distributing that negative 3x to all three of these. Then you are going to subtract. When you subtract, you are going to change the sign. So it's going to be plus, 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 right? Minus a negative goes to plus. And then from there, you are going to, that cancels, negative 9 plus 9. This is negative 3 plus 6, which is 3x squared. This is negative 7 plus 5, or I'm sorry, negative 7 plus 12, which is 5x. And then plus 9. And then finally, we're going to do it one more time. What times 3x squared is going to give me 3x squared? Well, that's 1. Positive 1, so I'm putting plus 1. When I distribute that 1, I get 3x squared plus 2x plus 4. I subtract going down. So minus, minus, minus. That cancels. 3x plus 5. Okay. So then my answer is the x squared minus 3x plus 1 plus the remainder, 3x plus 5, over the divisor, the thing you were dividing by, which is 3x squared plus 2x plus 4. If they just asked for quotient and remainder, you would say the quotient is up here, the x squared minus 3x plus 1. The remainder is the 3x plus 5. Okay. Next one is going to be one that's going to show, like, when I have an x squared and then a constant, notice I'm missing an x term. I have to say x squared plus 0x minus 2. Every place has to be accounted for, just like it would be in synthetic division. And this one will be a 3 or a x to the third, no x squareds, minus 3x plus 4. So every place has to be accounted for. Okay, I'm putting 3 terms into 3 terms, so my first is going to go up there. What times x squared is going to give me x cubed? That would be an x. So x times x squared is x cubed. X times 0x is, I'm going to put plus a 0x squared, which is really 0, but I'm trying to line up the places. X times negative 2 is negative 2x. I'm going to subtract going down. So minus, minus, plus. Those cancel. These actually happen to cancel. And I get negative x plus 4. Now, I can't put an x squared into an x, so that lets me know I'm done. So my answer could be x plus remainder over divisor, or if it's just asking me quotient and remainder, quotient is the x, remainder is the negative x plus 4. All right, this is the last one we're going to do. So this is a degree 1. Okay, so we know we can do synthetic division, right? But because the leading coefficient here is not a 1, we're going to see we have to do something in the end to get the answer correct. So normally when we're doing synthetic, right, we set this thing equal to 0, right? We get 2/3. 2/3 is what would go in our box. Also, I know some of your teachers last year put the box maybe on the right. If you Google any videos on synthetic division, you'll notice they're always on the left. It doesn't really matter. I don't care if you're used to putting it on the right, you want to put it on the right, that's perfectly fine with me, but just kind of explaining why I'm putting that on the left. So 27 for the x cubed, 9 for the x squared, negative 3 for the x, and negative 10. 27. Okay, so 2/3 of 27 is 18. Add going down. So again, 2/3 of 27 is 18. Add going down. 2/3 of 15. So 2/3 of 15 is 10. And it divides in evenly. So it looks like 27x squared plus 27x plus 15 is our answer. Now, actually, it's not. What we have to do is, since this is over 3 here, it's 2 over 3, we actually have to divide this by 3 to get the answer. So it's 9x squared plus 9x plus 5. That's our answer. Now, to kind of prove that to you, if we did long division, I can kind of show. So that's why it says complete this one twice. We're going to do long division. So I'm going to say what times 3x gives me 27x cubed, right? So the first that I put up here times the first here has to give me the first here. So that'd be a 9x squared. 27x cubed. 9x squared times a negative 2 is negative 18x squared. Subtract going down. So this is a good review again of long division. So minus, that goes plus. So then this cancels. 9 plus 18 is 27x squared. Bring this down. Divide. So this would be 9x times 3x. That'll give me a 27x squared. 9x times negative 2 is negative 18x. Subtract going down. So then we get 15x. Bring down the minus 10. And then one more time. That would be 5, right? So that's 15x, right? Because 5 times 3x, 15x, 5 times negative 2 is negative 10. If I subtract something from itself, it's going to be 0. So you can see either way, my answer works out to be 9x squared plus 9x plus 5. But if you're going to use the synthetic division, you have to know, since this is a fraction over 3 that you're dividing by, at the end you have to divide that by 3. But you could always just do long division. If like the leading coefficient is not 1, it's a degree 1, right? Because it's x to the first. But if that leading coefficient is not 1, then you have to do the long division. All right, and then that's it for day 1.